Great. So this is the second section here. Tour of the periodic table. I am your tour guide. Get it? No? Okay, fine. Anyway, just some kind of facts of the periodic table. Things I expect you to know. A couple of definitions here. It's a pretty short section. And then we'll be kind of done with this. And then on to trend, which will take us a few more days, a couple days. So, the periodic table is, as we mentioned, if you remember from whatever, Thursday, Wednesday, last week, very diverse. There's lots going on there: solids, liquids, gases, metals, non-metals, etc., etc. We number them kind of in two ways. I mentioned the important columns, the tall ones, we can call 1 through 8 sometimes, but some other times I'll just refer to them like by absolute numbers. This would be 1, 2, and you count all these for 12, 13, 14, 15, 16, 17, 18. So I'll try to reference both here. But if you just count them all absolutely, elements in group 1 and 2 and 13 or 18, the tall columns, they're called the main group or representative elements. Main group or representative. Notice those are all the tall columns. You might just want to write tall groups on there so you know that's what we're talking about. But they're called that because they represent everything on the periodic table: metals, non-metals, solids, liquids, gases, without all the complications that you get when you start talking about d orbital electrons, the ones that are in the middle part here. So they're pretty easy. We can work with them a lot. We're going to look at the main group, for this whole week. We're not really going to talk that much about d orbitals and what that means. Notice, and I think I kind of reviewed this the other last week, all of these are S's and then skip, and all of these are P's, and this block in the middle is the D's. So we're really talking about the S's and the P blocks. This is, for example, 4S2, 4S1, or P2, and P3, etc., etc. So all the ones that end in S and P are the ones we're talking about. As I mentioned, they're called representative elements because they have a wide range of properties: solids, liquids, gases, metals, non-metals. High density, low density, high melting point, low melting point. Oh, don't yawn. 4 groups that you need to know by name. Remember, groups of the columns. The first group, or column 1, are called the alkali metals. So we're going to refer to them as group 1. Alkali metals. Those are the 3 that I just reacted: sodium, lithium, potassium. You can see some of their properties. That's just one of their properties. But soft, malleable metals that react fairly violently with water. Second, alkaline earth metals. Those are group 2, or the second column in the periodic table. You've probably heard the term alkaline for what?
Battery.
Batteries. Yep, they're using batteries.
Periodic tables.
And the periodic table, yeah, they're also in the periodic table. So these tend to associate with bases, which are go hand in hand with batteries. And so beryllium, magnesium, calcium, strontium, especially these 4 here: magnesium, calcium, strontium, barium. Those are usually associated with bases, and so that's where the alkaline comes in. Or you heard them in your what? Your hot tub. If your hot tub is too acidic or too basic, what do you put in if it's too acidic? That's if it's too basic. pH down.
Oh, yeah, I said pH.
Yeah, down. What was the other one that you put in? Baking soda. So sodium ion. Well, sodium carbonate.
But you have an acidic.
Halogens are group 7 or 17, the second to last column. They have lots of properties. Halogens use, for some of those gases are used in like halogen lights for your cars. I think I mentioned this already. A combination of them give you, the typical car headlight that you would see. Usually that's iodine, but there's others: chlorine, bromine, iodine. Those are the 4 halogens. And noble gases in the very last column, group 8 or 18, depending on how you're numbering it. Noble gases don't react to anything, at least well. They don't make lots of compounds. They're very happy because they have 8 valence electrons, so they don't do that much. They're very stable. That's what they call the noble gases. Sometimes called the inert gases. Inert meaning if they don't react with anything. That's why those kind of metals that were will react with air very easily, like the potassiums. They're packaged in usually argon or something that's easy then to buy that is very inert. So oh, it's kind of coming back there. I think I said this very quickly. Alkali metals have one valence electron. They would love to get rid of, so they're very reactive. Did I show you any of the videos with the guy with the hair? On the periodic table? I think I was going to and it didn't work out or something. I'll try and show you later.
You like the 70s movie?
No, it's not the 70s video. It's like,
The dude where he lets the balloon go?
no, this is better.
It's the
Well,
YouTube,
sort of
that's
better.
why we couldn't get our. We watch it.
That we've mentioned. Halogens. They have 7 valence electrons. And they're going to react to get that one more valence electron. They're super, super close to 8. They just need one more. We're kind of setting up how bonds happen. Some elements would love to get rid of electrons. Some elements would love to get electrons. And then those are the ones that form bonds very easily. And that's kind of what we'll come back to for next chapter.
We're done.
What? No, that'd be nice though. Sodium, just really quickly. 1s2, 2s2, 2s, 2p6, 3s1. Is that right? That's right. When we say that sodium has one single valence electron, that's this one right here. They would love to get rid of that valence electron. When they do, if you get rid of it, notice you've got 2s2, 2p6, and so it's a lot happier because now that's when I say like get down to 8. If you get rid of this, you lose one, and you got. I mean, it sounds backwards going from 1 to 8, but if you lose this one valence electron, now you've got 2s2, 2p6, and there's your magic number 8. So it makes it a lot happier to get rid of that valence electron. On the other hand, something like fluorine is 1s2, 2s2, 2p6. Nope, 2p5. Sorry. So here's your 7 valence electrons, 2s2 and 2p5, 2 plus 5 being 7. It would really love to have one more valence electron, so then it could be very stable at 8. And so that's when they gain 1 electron needed to have the 8 valence electrons and the filled outer energy level. So you can see that there's going to be a situation where you take this 1 electron and give it to that element, and then they form a compound. That's kind of what next chapter is going to be
How
all
do
about.
you show that?
How do you show if they form a compound?
Yeah.
Over the next chapter. You can show it by drawing some arrows and those Lewis dot structures I showed you.
Oh, yeah.
That it's got 1 valence electron. This has 7, and so it would love to give this electron here. And so that's what's going to happen next chapter. But don't be confused when I say get down to 8, because that's what you need to get down to 8. We're doing great, you guys. I really appreciate your focus. Is that it? We're almost done. Noble gases don't react to get a full set of valence electrons, a full set of electrons in the outermost energy level, and so they don't do anything. No.
I thought you were signing off.
Just waiting. Everyone's seniors in the corner. Hydrogen here is in the first column or the first group. It's kind of in a spot by itself, so don't consider it an alkali metal. It's kind of in its own little world. It can do, when it readily gives up its 1 valence electron. It's got just 1 proton, 1 neutron, 1 electron. So it's kind of got some special properties that we kind of consider it in a class by itself. It is the most common element in the universe. I don't know why you need to know that. But because it's just got 1 proton, 1 electron, it behaves like any other element. So when we talk about alkali metals, we're really starting sort of here and not counting hydrogen. And on the same token, helium, which you put over there, could fit right here, right? I mean, it's got 2 valence electrons, just like this does. Except when helium, we put it over there because it's not very reactive. Because that when it fills its 1s2, it fills that one energy level, and then it's happy. It doesn't really want to get, 6 more to fill. And so instead of filling the 2s2, 2p6, it just fills the 1s2, and it's very happy. So helium is placed over there, even though technically it could be over there. Okay. Awesome.
Yeah, we're done.
Most of the elements are metals in the periodic table. these two columns, these two groups, this entire section, the stair-step line in your periodic table separates metals and nonmetals. So everything on the left side of the periodic table is metals. The vast majority is metals. Okay. Also, these really belong in here, and so they're still metals too.
What's
These,
that thick line spread?
just showing you that they go like right here. Like that. This whole section, see how it goes from 56 to 72. Here's your 57, 71. The reason they put this section down here is so that it doesn't make the periodic table like this long and hard to put on a piece of paper. So just cut out this section and put it down here. Super grand. But these are all the F ones, which we never learned on the chart. It goes, you know, S, P, D, and then the last one is F. And so they just take out the F block and put it down here. All the ones that are outlined. So metals, nonmetals, the stair-step line is what separates them. Along the stair-step line you have something called metalloids, which kind of have properties of both metals and nonmetals. For example, silicon is a great metalloid. It has got properties of metals and nonmetals. But for the most part, I'm just going to say everything on the left is metals, everything on the right is nonmetals. Properties of metals, they are malleable, they are ductile, and they conduct electricity. Ductile means you can squeeze it onto a wire like a copper wire. Greenhouse gas.
Can you
Because it's got 7 spots. Instead of having 5 lines, it's got 7. Alright, so all metals conduct electricity, as you saw in that great video with the guy doing the thing in the woods with the flute. And then, did you see that part with the
Yeah,
that was weird. This means recorder. So you can squeeze out metals into a wire. Copper wires are really common, you know, for your sweet iPhone ear noises. What is it?
headphones?
Headphones? I was gonna say that, but I didn't want to like date myself. Are they called like earbuds now? If you're cool.
No.
Okay, so your headphones have metals, have copper wire. These,
Earbuds.
all of these wires are usually copper. The ones that get in the way of the video, or the ones that you know run sound, or even cable. It's just a series of copper wires. Anyway, malleable. Does anyone know what that means?
It cannot.
No, it just means that they're you can hammer them into sheets. Most metals are malleable, which means you can hammer them or roll into sheets, which makes them very useful. For example, rolling out aluminum, making aluminum cans, or
Aluminum foil.
plating. Aluminum foil. Plating your metals, your like precious metals. You can take, this is like probably a piece of plastic just covered in gold leaf. But anyway, you can. I know it costs like $10.
Really?
Well, it was pretty cheap, not that cheap. But
How much did you spend on hers?
I got it from my grandma. Boom.
Awesome.
Isn't that romantic?
Yeah, it's on video, so we're watching.
I'll show it to her.
Does she know?
What's that? She doesn't know. She has no idea. She knows.
She knows. That's cool. Oh, she wants it?
You're like,
That is cool.
no, someone stole it.
It's okay. We have lots of debt from other places, so it doesn't matter. Anyway, doesn't matter if I bought a $5,000 ring. We spend that money.
I was just thinking.
You know what I'm saying?
Yeah.
You know what I'm saying? Long-term
Yeah.
relationship. Anyway. Anyway. And long-term, right? Yeah, it's like a year or something. I know. Facebooked him. Anyway. Metals can be rolled into sheets. If you've ever seen gold leaf before, it's really, really thin. You can take gold and pound it really, really flat to, even thinner than a piece of aluminum or aluminum can. Very, very, very thin. All right, so metals conduct electricity. They're ductile, they're malleable. Non-metals aren't, which I think we'll get to in a second. Transition metals are the ones in the middle here, the D block metals. So these got a name. Alkali, alkaline earth. All of these in the middle are called transition metals because they transition from metals to non-metals. They're the ones that end in the D. They're the ones in the middle, which we don't count. Transition metals are less reactive than alkaline metals and the alkaline earth metals. when you start to involve those orbitals, the d orbital, things get funky. They're not as reactive. They can form more than one kind of compound. That's why you see a lot of precious metals here that don't react with a lot. Gold. When you find gold in the wild, in the mines in Africa, it's pretty much well kept, right? It looks perfect because it doesn't react like over the millions of years that it's been in the Earth's crust or whatever. It doesn't react with anything. Same with platinum or silver. They don't have to do a lot to process those things because they are very unreactive.
For sure.
Oh, hey! How do the elements get their names?
A lot of the names are Latin. Some of them aren't. Yep. Yeah, so that's named after quad. You can take, oftentimes you don't think of solid mixtures, but you can take metals and melt them down to make, and then mix the two metals together to make alloys. That's where you get like, 24 karat gold or 14 karat gold. Those are just a measurement of how much actual gold is in there. Usually it's mixed with some other non-precious metal. This is probably like 2 karat gold or something, which would make it really terrible. But you can take the metals, melt them, and then mix them together to make different alloys of things. For example, steel. If you remember a couple of years ago in the, couple of years ago or last year, the Summer Olympics.
Yeah, I remember that.
2 years ago?
2 years ago.
Not this summer, it was the previous summer, right? They had that crazy bird's nest place, right?
China?
In China, the Olympic Stadium was it was called the bird's nest. It looked like a bird's nest. They had to invent a different alloy of steel to make that. So the one that was very, able to be bent, but also very, very strong. And so steel, there's like 1,000 different kinds of steel, okay? And they're made for all different purposes. Some use in bridges in certain places that are more water resistant. Some of them are more able to be bent. Some of them are stronger. Some of them are more brittle. And so it's just a matter of how you add the different elements to make that steel. Iron would be one of them, and then I would guess, I don't know what else goes in there, but iron is the chief component. But you melt all those metals together, you mix them together as a liquid, and then when they cool, that's how you get steel. And there's literally thousands of different kinds of steel.
Pretty sure it's iron and coal.
Iron and coal, iron and carbon. Carbon probably does go in there. The properties of an alloy are different from the properties of the individual elements. That's what makes certain gold, same situation. Certain gold, if you have 24 karat, is softer, I think, than 16 karat. I don't know the rules, but there are lots of different rules. The more gold you use, the softer it is, easier to be able to be bent. I think that's good. Do you have any questions about the tour of the periodic table? Quickly. Yeah. Alkaline earth, transition, non-metals. On here, someone asked what the colors, if you didn't hear. On this periodic table, black means solid at room temperature. Blue means liquid at room temp. Green means gas. So most of them are going to be solids. Metals conduct electricity. They're malleable and ductile. Non-metals aren't. If they didn't show you can't if you tried to hammer that piece of sulfur he had when he connected the needles to it, it would smash. Non-metals are brittle. They break very easily. So they're very different than stair-step line separates them. And go ahead, question.
Oh, isn't this the gas line thingy?
No.
Or the separates the
Metals and non-metals.
Oh, yeah.
And then just some of them the non-metals happen to be gas at room temperature, but phosphorus and sulfur and carbon, those are non-metals, but they're solids. Well, you could make it a gas, but
It smells really
at room
good.
temp it's going to be a solid. Other questions?
Can we get our homework? Scroll down.